Hi guys, good evening. So from machine section, we have only the one question that is come from instrumentation engineering. And that question is from induction machine. So let's see the solution of this question. This question is very simple question. And this type of question also asked yesterday in electrical. So let's the solution of this question. We have 448 kilowatt 4 pole 50 hertz star connected induction motor has full load slip of 0.04. The rotor speed is asked. The rotor speed is asked at full load. The rotor speed is asked at full load. So first we have to know what is the speed of rotor at running condition or at full load. Full load, that means at running condition. And basically for the machine, the load is, for the motor, the load is mechanical load. And for the mechanical load, and how it will be a load when a motor rotate that load. Okay, so our motor is running at full load speed. So we know that induction motor rotor speed is less by slip speed. If the speed of RMF or rotating magnetic field is ns, then rotor speed is slip speed, that is SNS. Simple. The speed of the rotor is slip speed, synchronous speed minus slip speed. Okay, so synchronous speed minus slip speed. What is synchronous speed? ns. How to find ns? 120 f upon p. 120 f is 50 and number of poles is 4. Number of poles is 4. It is 1500 rpm. That is the speed of rotating magnetic field. That is 1500 rpm. So the speed of rotor is less by slip speed, that is SNS. So what is the slip? We have the slip at full load is 0.04. So 0.04 is the slip at full load multiplied by SNS. (15 into 4) 60. So 1500 minus 60, it is 1440 rpm. That is the speed of rotor at a full load. That is the answer of this question. Very simple question. Very simple question. And this type of question is also asked yesterday in electrical engineering paper. Okay. So that's all. Now keep watching. Next subject will continue. Okay, thank you.
Hello. हो जाएगा तो देंगे. Hello everyone. So now we are going to take few number of numericals based on the concept of mathematics, control and analog. So let me focus over the first question, and probably you must have solved this problem easily. This problem is being based on the concept of rank and determinant. So let me bring this problem towards working board and we would try to smash that problem there only. So this has been the problem. What the problem states, given M is being a square matrix, the first row entities are being 2, 3, 7, 6, 4, 7, 4, 6, 14. Which one of the following statement is R correct? The four different options are being attached. The first option is being the determinant of M is being 0, the rank of M is being 3, the row of M are linearly independent, and rank of M is being 2. Once you'll focus over this square matrix, no, one thing is being quite clear. Row 1 and row 3 is being linearly dependent. How did I know about it? You can easily guess the row 3 is being 2 times of row 1. That means R3 and R1 is being linearly dependent. And as R3 and R1 is being linearly dependent, if you will be in search of its determinant, the determinant is simply going to be 0. So obviously the option A is going to be 0. Otherwise you could have taken another alternate. That alternate could have been R3 tends to R3 minus of 2 times of R1. In that case, the third row must have been 0. And if in any of the square matrix the complete row or the complete column vanishes, the determinant used to be 0. Yes, sir. If we'll be talking about the rank of M, as far as the determinant of this 3 cross 3 matrix is being concerned, determinant is being 0, so obviously rank cannot be 3. It has to be fewer than 3. So option B is also been ruled out. If we'll be focusing over the row of M are linearly independent, no. R1 and R3 is being linearly dependent, so the C is also been ruled out. And if we'll be focusing over the rank of M, what had been the rank of M? One thing has been quite sure, R3 and R1 is being linearly dependent, and then we would be taking out the minor of 2 cross 2, and if all of the minors of 2 cross 2 is being 0, in that case we will be searching for the rank of 1. But if we will be taking the minor which contains the data as 2, 3, 6 and 4, its determinant is being non-zero, and as the determinant is being non-zero, obviously we can say the rank is being precisely 2. So the student who had given the answer as A and D, that had been the best most answer. A and D has been the best most answer. Yes, in the same sequence I think it's been the right time taking the next question as well. So here comes the next question. Yeah, this problem was a problem from concept of differential equation. The problem was the problem of non-linear differential equation. Can be easily solved with the help of variable separable technique. Here comes the next question. So the solution starts from here. The problem states that the dy by dx plus of y ln of y is being 0. This has been first order first degree differential equation. Dy by dx plus of y ln of y is equals to 0. Initial values which are being supplied along with this problem is being the value of y at x is equals to 0 is being e. Then I need to find the worth of y at x is equals to 1. Then I need to find value of y at x is equals to 1. 4 different options are being attached along with this problem. Once we'll be focusing over this differential equation, one thing has been quite sure. Function of y can be easily separated with dy, and the function of x can be easily separated with dx. Put together, this problem is being a standard problem of the variable separable technique. Yes, we would be using variable separable technique. We would be using the variable separable technique. What we would be doing over here? This complete factor has been brought towards right hand side, the dx had been towards left hand side, and we will be flipping it. So here dx divided by of dy is equals to, already it had been brought towards right hand side, and as the inverse has been taken place towards left hand side and right hand side, so this also becomes 1 divided by of y ln of y with the negative sign. With the negative sign. Obviously, sir, we can understand what exactly you wanted to communicate. So in the next step, what we would be doing over here, we would be converting this problem into the standard form of variable separable method, where the function of x is being separated with dx, and similarly the function of y is being separated with dy, and the integration is being operated both on the side, and end of the day you will be getting its general solution. And by feeding x is equals to 0, by feeding y is equals to 1, e at x is equals to 0, we can find its particular solution as well. Yes, na? Yes, sir. So what we are going to do over here, we are going to take the integration both other side. Which one? This one. Dx remains dx is equals to of minus of dy divided by of y ln of y. Y ln of y, the integration is being taken both other side. Arbitrary constant c had come into the picture. So in the same sequence, when we will be taking the integration of dx, the result which comes into the picture is being x. Similarly, the minus sign has been brought out, and what we can do over here, we could have taken ln of y as t, and once we take ln of y as t, once we take its differentiation, 1 upon y dy becomes dt. So yes, here it becomes minus of dt divided by of, see, 1 upon y dy itself is being dt, and ln of y is being taken as t plus of c. Still it has been plus of c. Yes, sir. So x remained as it is, minus remained as it is, anyways it's been plus, sorry, it's been plus. The integration of 1 upon t has been ln of t. It's been ln of t. Ln of t, and may I know what had been the t over there? The t has been ln of y plus of c, plus of c. This has been the general solution where the c has been an arbitrary constant. This has been the general solution where the c has been an arbitrary constant. The data which has been supplied along with this problem states the value of y is being e at x is equals to 0. X has been fed as 0. Value of y is being fed as e. Keep in mind here the log is being log natural. So here it comes ln of e plus of c. As we know, ln of e is being 1 and ln of 1 is being 0. So the value of c which we have got out of this calculation is being simply 0. So I think it's been the right time focusing over the particular solution. So x would remain as it is, minus of ln y would remain as it is, and the value of c would be fed as 0. Now what we had been doing over here, the minus sign is being shifted towards right hand side. So here it becomes minus of x. Now this ln has been shifted towards left hand side. So here it becomes e to the power of minus x, and again this ln is being shifted towards left hand side. So here the result what we get, or the particular solution what we get, it's been y is equals to of e to the power of minus x, e to the power of minus x. Yes, na? Yes, sir. So end of the day, we had to find the value of y at x is equals to 1. So here simply we had to find value of y at x is equals to 1, and that becomes e to the power of minus 1. Virtually speaking, this can be written as e to the power of 1 by e. Whoever have got the answer is B, definitely that had been the appropriate most answer. Is that part clear to all of us? In the same sequence, I think it's been the right time focusing over the next question as well. So this has been the question from the control system, a very straight question. If you had a little bit idea about the signal flow graph, probably within fraction amount of second, you can smash this problem easily. So here comes the next question. This has been a standard problem from signal flow graph. What the problem states, the signal flow graph of a system is shown, the expression of y of s over x of s is being. The four different options are being attached. This has been a type of MCQ. My dear friend, as we had to calculate the ratio between y of s divided by of x of s, the forward path is being the path which starts from x of s, and without repeating any of the node in the direction of signal flow, we reaches to the y of s. Probably Mason's gain formula must be known to all of us. I am just going to use that standard formula. So here it becomes y of s divided by of, here it becomes y of s divided by of x of s. Is that part clear? Y of s is equals to of x of s. Y of s divided by of x of s is being defined as the discrete sum of pk del k divided by the determinant. How many number of forward paths we have over this problem? Tell me. How many number of forward paths we have over this problem? This has been the first forward path. Let me focus over here. This has been the first forward path, and this has been the alternative second forward path. So the number of terms which we are going to have of towards the numerator side is being simply 2. So obviously if we'll take that reference, no, only option D is going to be correct one. Anyways, let me focus over here. So first gain is being G1 into G2. I am not writing S business and all. So it had been G1 into of G2 plus. The second one is being G1 into of G3. Yes, sir. G1 into of G3. And the associative factor with both of the terms are being 1. Because no loop has been left out once we had been going through G1, G2 and G1, G3. Yes, sir, that part has been agreed. We will be focusing over its determinant. How many number of loops we had? The 2 number of loops we had. May I know what are they? This has been the first loop, and similarly, which one? This has been the first loop, and this has been the second loop. And both of the loops are been touching. That means you are going to have the factor of 1 minus the gain of the individual loop. The first gain is being minus of G2. Obviously, S is going to come. Minus of G3. Yes, sir. So, end of the day, the result which we are supposed to get for this problem is being G1, G2, G1, G3 divided by, at denominator side, we are going to have 1 plus G2 plus of G3. So, whoever have got the answer as G1, G2 plus of G1, G3, obviously S is also going to come everywhere because the G1, G2, G3, they all had been the function of S divided by of 1 plus G2 plus of G3. This has been the bestmost answer. Let me go forward. Let me take the next question here. Yeah, a very straight question. If you had a little bit idea about the state space analysis, easily you would be able to crack this problem out. Let me bring this problem towards working board, and we would be doing sort of surgery with this problem. So here comes the question number 8. Here comes the question number 8. What the problem states? The transfer function of a system, the number of zeros which had been involved with this system is being 2, and similarly the number of poles which are being involved with this system is being 3. In the state space representation of the system, the minimum number of state variables which are being required. My dear friend, you must be knowing about this particular fact. The number of state variables which are being involved with any kind of control system is being the order of the differential equation. The number of time constants which are being involved with the given differential equation or given equation, or the number of poles which had been associated with the given transfer function, or I can say the number of roots which are being involved with the characteristic equation. If we take this as an open loop transfer function, then also the number of roots which would be involved is simply going to be 1 plus this factor is equals to 0. So obviously it is going to be a cubic equation. It is going to be a cubic equation. Is that part clear to all of us? This is going to be a cubic equation, and as this has been a cubic equation, definitely the number of roots which are being involved is being 3, and as the number of roots which are being involved is being 3, again I can say the number of state variables which are being required for this given question is being precisely 3. Either you take this as a OLTF, either you take this as a CLTF, in both of the cases the answer is going to be 3. Is that part clear to all of us? So I don't think any of these students must have made mistake over this point, and whoever had given the answer as 3, definitely that had been the precise most answer. That has been the precise most answer. In the same sequence, I think it's been the right time focusing over the next question as well. The question number 9 is not a complete question, so let me see how the circuit is being missing. Anyways, we can have the next question from the mathematics, engineering mathematics, and that had been the question number 10. That had been the question number 10. So this question had come over here. What the problem states, the Newton-Raphson method is applied to determine the solution of f of x is equals to 0, where f of x is equals to x minus cos of x if the initial guess of the solution is being x naught is equals to 0, the value of next approximation x1 is equals to 0. x1 is equals to 0. May you know why the Newton-Raphson method is being used? The Newton-Raphson technique or Newton-Raphson method is being used to solve algebraic equation and transcendental equation. Anyways, this is not the right time to discuss about the detailed analysis of this pattern of the equations, but one thing has been quite sure. If fx is being taken as 0, fx is being clearly given as a x minus of cos of x, so the equation which had come in our hand, it's been a transcendental equation. Yes, it's been a transcendental equation, and basically we are in search of the value of x which satisfies this transcendental equation, or I would say left hand side is being very same as the right hand side. Yes sir. Let me use the formula which we use in case of Newton-Raphson. Anyways, a little bit derivation part is being involved. If you want, I can show you the derivation from where the formula which we use in case of Newton-Raphson had come into the picture. But anyways, we know the x new is equals to of x old minus of f of x naught divided by of rate of change at x is equals to x naught. At x is equals to of x naught. The x naught is being the first approximation that had been clearly given over this problem, that had been 0. Obviously sir, understood. The function f of x is being clearly known. F of x is being clearly known. F of x is being x minus of cos of x. But here x would be fed as x naught and the x naught is being 0. So what we are going to do over here, x is being replaced with 0 minus of cos of 0. And towards denominator side, first we would be performing its derivative. So the differentiation of x minus of cos of x is being simply equals to 1 plus of sine of x, and then we would be feeding x is equals to of x naught, and that had been 0. That had been 0. So the answer which we are supposed to get after doing this all stuff of calculation is being 0 remained 0. 0 remained 0, and here minus and minus becomes plus. That had been plus of 1 divided by of sine of 0 is being 0. 1 divided by of 1 is being 1. So I can say the next approximated value with the help of Newton-Raphson technique is being precisely 1. So whoever student had got the answer as 1, that had been the appropriate most answer. Appropriate most answer. Is it part clear? Let me focus over the next question as well. So here comes the next question. This has been a problem based on the BJT DC biasing. Let me focus over the problem and then we would try to figure it out which could be the best method to approach this problem. The problem states, in the circuit shown R1 is being 100 kilo ohms. The worth of resistance is being 100 kilo ohms. Similarly, the value of R2 is being 1 kilo ohm. If the base to emitter voltage of NPN, obviously if the BJT is being on, base to emitter voltage in case of silicon based BJT used to be 0.7, and that had been clearly supplied along with this problem. That had been 0.7, yes sir. And the collector to emitter voltage, this voltage is also being given, or I would say collector to emitter where the emitter is being perfectly grounded. So the value of VC is being given as how much? 5.2 volt. 5.2 volt, and in this problem we had been in search of beta. I need to get the value of beta. I need to get the value of beta. My dear friend, if the value of VC has been 5.2, no, few of the important conclusion we can deduce. The first important conclusion, the BJT is not in saturation region. If the BJT must have been in saturation region, the voltage across the collector to emitter terminal must have been VC set, and VC set is very small in value. It must be 0.2, it must be 0.1 or 0.3. One thing has been quite sure, the BJT is not been in saturation region. So yes, you don't have to worry about the mode as saturation. No, saturation is being ruled out. Saturation is being ruled out. Saturation is being ruled out. That's been the first thing. Yes sir. Even the cutoff is also ruled out. If the cutoff, the BJT must have gone into the cutoff region, the value of IB and IC must have been 0. So all the way this 12 volt must have come across this terminal and VC must have been 12 volt. So yes, cutoff is also being ruled out. So in this problem, you don't have to have a second thought. You just presume that the BJT is been working into the active region. And yes, IC is going to be beta times of IB. IC is going to be the beta times of IB. Taking this psychic in our mind, we would be processing forward. See what had been happening. Just try to understand. 12 minus of 5.2. 12 minus of 5.2. So here 12 minus of 5.2, so the value is being somewhere 6.8. 6.8 is going to get divided with 1 kilo. So the current which has been flowing through this resistance is being 6.8 milliampere, and that had been the value of IE. Agreed? And the IE used to be 1 plus beta times of IB. Why I had been taking the reference of IB, that you can see here. That you can see over here. Yeah. Now, all the way you can see this voltage is being 5.2 and this voltage is being 0.7. So, the voltage difference between these two terminals is being 5.2 minus of 0.7. That had been 5.2 minus of 0.7. So, the potential difference is being 4.5 volt. 4.5 volt is going to get divided with how much? So the result which we are supposed to get over here has been 45 microampere. 45 microampere. Yes, na? This data is being placed over here. It's been 45 microampere. So the worth of 1 plus beta is equals to 6.8 divided by your 45. This has been milli, 10 to the power of minus 3. This has been micro, 10 to the power of minus 6. They had been smashed together. So the worth which we had been getting over here is being 10 to the power of 3. 10 to the power of 3. So the result which we are supposed to get, it's been 6.8 divided by 45. 45 into 10 to the power of 3 into 10 to the power of 3 minus of 1. Minus of 1. The answer is approximately somewhere 150.11. 11. So as per the data which I had received, the value of beta is supposed to be 150.11. Agreed na? Okay sir, agreed. Let me take the next question. This question is already been taken. There was one more question actually. Yeah, this was the problem from the concept of R to 2R ladder. So let me bring this problem towards working board and we would try to smash that problem there only. Problem states a resistor ladder DAC converts receive a digital input that results in the circuit having the state as shown in figure. For the digital input, the Thevenin voltage VTH and Thevenin resistance RTH as seen the output node R. Anyways, a little bit derivation part is been involved, but I am not going into that detailed analysis. See, here the switch is being intacted to ground. So if you will go from the initial node, if you'll go from the initial node to the last node, if you'll go from the initial node to the last node, how many number of steps are being taken? 1, 2, 3. But as it had been connected to the 0, no, so the effect of this switch or this voltage is being simply 0. We had been using the concept of superposition. Yes. Now this switch is being intacted and all the way it had been connected to the 4 volt. And number of times the transition is being taken place. This has been the first time, this has been the second time, this has been the second time. So what had been happening? 4 volt is going to get divided with 2 to the power of number of steps the chatter had been taken place. How many times the chatter had been taken place? It had been 2 to the power of 2. 2 to the power of 2. Apart from this switch, no one is being connected to the 4 volt. So the value which we had been getting as a RTH now, that had been simply 4 divided by 4 and that had been 1 volt. 1 volt. As far as this problem is being concerned, yes, D had that answer, 1 volt, 1 volt. So the value of VTH which we had received is being 1 volt. If we'll be talking about the value of RTH, may I know what would be the value of RTH? We had to take its equivalent circuit. All of the external voltages have been removed. 2 comes in parallel with 2, that's been 1, comes in series with 1, that had becomes 2. 2 in parallel with 2, that's been 1. In series with 1, that's been 2. Comes in parallel with 2, that's been 1. So the value of RTH is been 1 kilo ohms. 1 kilo ohms. So the student who had given the answer as 1 volt and 1 kilo ohm, that had been the appropriate most answer. In the same sequence, I think it's been the right time we would be focusing over the next question as well. There were certain mistake in this problem, but still we would try to take this problem over here. Again, it had been a MSQ type of problem. That means this question may have more than one answer. This question may have more than one answer. A matrix A is equals to a 4, 3, 9, minus 2 has the eigenvalues minus 5 and 7. The eigenvector is being. The eigenvector is being. So probably you must have seen eigenvector corresponding to a eigenvalue is being a non-null vector matrix which follows this equation. AI minus of lambda into a non-null matrix is equals to 0. We would be taking the reference of lambda is equals to of minus 5. So this factor becomes, how much this has become? 4 minus of minus 5, that had become 9. Just a minute. That had become 9. Here we had 3. And then 9 remains as it is. And then minus 2 plus of 5. Minus 2 plus of 5, that had been 3. That had been 3. Yes. We had to use a vector quantity such that this equation must get satisfied, or the number of equations which we can deduce out of it, it's been 9 times of x1 must be equals to, or plus of 3 times of x2 is equals to of 0, or I can say x2 must be equals to of minus 3 times of x1. We can see very well in this problem where this data is been matching. x2 must be minus 3 times of so the answer which we are supposed to get now. Similarly, we would be taking the reference of 7 as well. Once we take the reference of 7, the result which we get, ma'am, khatam hone wala hai. So the result which we are going to get, it's going to be 4 minus of 7 is been minus of 3, then of 3, then of 9, and then of minus 2, minus of 7, that had been minus of 9. Minus of 9. So obviously here the x has to be 1, 1, 2, 2, 3, 3. So the result which we are supposed to get, it's been option, and probably it's gonna be option D. Option D. So now it's done for the aptitude, and once again I would be taking few more number of questions. Okay then. Okay ma'am, please. मैम आपको इमेज मिला है नहीं? चलो ठीक है. टाइप हो गया और नहीं हुआ है? नहीं हुआ.
Okay, hello everyone. So let's start with the very first question which we have in general aptitude. We have two inequalities. The first one is 3p minus q, that is less than 4, and the second one is 3q minus p, that is less than 12. Now it is given that which of the following expression below satisfy the above two inequalities, and we have options like 8 p plus q, 16. Option number B, p plus q, that is equals to 8. Option number C, p plus q is greater than or equal to 16, and the option number D, p plus q, that is less than 8. Now what we have to do first, as we have two variables and two equations, what we will do, we simply add both the equations. Add equation 1 and equation 2, right? So if we add both the equations, what we will get, we will get 2q plus 2p, that is less than 16, and here we will get 2 as common, q plus p, that was less than 16, and here we will get q plus p, which is less than 8. That means the correct answer is option number D. The correct answer is option number D. This is very easy question. Now let's move to the next question which we have from the pipes and systems. It is given that we have two pipes. First one is P and the second one is Q. Sorry. Here we have two pipes. First pipe is P, the second pipe is Q. P can fill the tank or cistern in 10 minutes, while the Q fills the tank or cistern in 6 minutes. Right? Okay, now R can drawn out water at the rate of 34 liters per minute. R draws out the water with 34 liters per minute speed, and PQR operate at constant rate. They all are operating on constant rate. If it takes 1 hour to completely empty the tank with all the pipes operating simultaneously. That means if all the three pipes are operating simultaneously, they will empty the tank. They will empty the tank in 1 hour. In 1 hour. We can write 1 hour as 60 minutes. Right? We can write 1 hour in 60 minutes. That means now what we have to do, we have to calculate the total capacity. For the total capacity, we take the LCM here, and the LCM is nothing but that is equals to 60. Right? That is equals to 60. So here we have 6, 10 and minus 1, because all these three, if they are operating simultaneously, they empty the tank. They empty the tank. So from this we can say the total capacity, or we can say the total efficiency of P plus Q plus R is nothing but that is equals to -1, but we know the efficiency of P is 6 and the efficiency of Q is 10. So what we have to do, we have to calculate the efficiency of R. So the efficiency of R is nothing but 17, right? Just to satisfy this equation, we have to calculate the efficiency of R, and we will get the efficiency of R is -17. So if we calculate in how much time R empty the tank alone, so time required by R to empty the tank, that is nothing but 60 by 17 minutes. 60 by 17 minutes. So it is given that R can empty the tank with the speed of 34 liters per minute. That means we can say in 1 minute R can empty 34 liters, right? R can empty 34 liters. So what we have to do, we have to calculate the capacity of storage tank. That means now the capacity of the time required by R to empty the tank is nothing but 60 by 17. That means 60 by 17. So we have to multiply this also by 60 by 17, and we will get our answer as 120 minutes. We will get our answer as 120 minutes. Is it clear? Is it clear to everyone? Now we have one question from the syllogisms, and we have three statements here. We have three different statements here, and what are these? We have three statements. Statement 1 says some engineers are writers. Some engineers are writer. The second one is no writer. No writer is an actor. And the third one is all actors are engineers, right? And here we have four conclusions as well, and they are: the first conclusion is some writer are engineer. Second, all engineer are actor. No actor is a writer. Some actors are writers. And here we have some of the options, like option number A, either C3, that means conclusion third, or fourth is correct. Option number B says only conclusion 1 and conclusion third are correct. Option number C says only C2, that means conclusion second, and conclusion third are correct. And the fourth one is only C1 is correct. Here, if we draw the Venn diagram, as per the given statements, So our diagram will be some engineers are writer. That means here we have engineers, right? And here we have some writers. No writer is an actor, and all actors are engineers. That means all actors exist here. That means they are the actors, and there is no relation in between these two, right? There is no relation in between these two. Now let's check the conclusion whether they follow or not. First one, some writers are engineer. Yes, if some engineers are writer, that means some writers are engineers also. That means first is correct. If first is correct, that means option number C is eliminated and option number A is eliminated, right? Next, all engineers are actors. All engineers are actors. We can only say the perfect thing about this part only. We can't say anything of this remaining part. That means this is false. This is false. And why this is false also? Because some part of engineering is common with the writers and no writer can be actor. So this second conclusion is definitely false, right? Third, no actor is a writer. No actor is a writer. That means this again correct. So first and third is correct. That means the option number B is correct. Option number B is correct. And some actor are writer, some actor writer, no. This is completely false. This is completely false, right? Okay, now let's move to the next question. This is from your verbal. Inhaling the smoke from a burning, filling the blanks, could filling the blanks you quickly. Now here we have option. The first one is tire and the second one is tire. Option number B is tire. Option number C is tire, and the option number D is tire and the tire. Okay, the meaning of this tire is levels. The meaning of this tire is levels. Inhaling the smoke from the burning tire. Here we need this tire. That means if we need first this tire in our first filler, that means this option is eliminated. This option is also eliminated. Now, inhaling the smoke from a burning tire could tire you quickly. That means the option number C is correct. This is a very simple question. Okay, now we have some memory based diagram. This is the top view of a building which have several rooms and the doors as shown in the top view of the house. Here we have some diagram, something like this. Here we have one door. This is a point P. And here we have Q, right? Now what we have to find out, the number of doors, the doors are closed initially. What is the minimum number of doors that need to be open in order to go from point P to point Q? What we have to do, we have to go from point P to point Q, and here we have some options. 1, option B 4, option C 2, and option D, that is 3. So as per the memory based diagram, P goes from this door. That means this is the door number 1 and this is the door number 2, and he will reach here. So the correct answer is 2. As per this diagram, the correct answer is 2. Now we have one more question from the mensuration. That is, a sphere of radius r is pegged in a box of a cubical shape. Okay. Here we have a sphere of radius r and that is pegged in a cube. What should be the minimum volume in centimeter square of the box that can enclose the sphere? Okay, so here we have options: 2r cube, b r cube by 8, c 8r cube, and option number D, r cube. So if this is the radius of sphere, that means the side of cube is 2r. Now what is the area of cube? Area of cube is nothing but a cube, that means 2r cube, and if 2r cube, that means the correct answer is 8r cube. That means option number C is correct. Option number C is correct. Now let's move to the next question. This is a question from the arrangement puzzle. Here we have 6 persons, P, Q, R, S and T and U are sitting around a circular table facing the center. Here we have 6 friends, or we can say 6 members, and they all are facing towards the center, and we have some of the conditions that P sits next to S and T. P sits next to S and T. So either S is here or T is here. So we can draw it like this. Now Q sits diametrically opposite to P. That means the position of Q is fixed here, right? Okay. The shortest distance between S and R is equal to the shortest distance between T and U. That means if here S is present, that means R should be here, and if T is here, that means U is here. Similarly here T, R and U. So we have to find out, based on the above statements, Q is a neighbor of, and we have options like P and S, option B U and S, option C R and T, option number D R and U. So what we have to do, we have to find out the neighbors of Q. We have to find out the neighbors of Q. So neighbor of the Q, either R or U. That means the option number D is correct. That means the option number D is correct. Okay, now let's move to the next question. Here we have one question from the probability as well. And what was that? Here we have a game. Okay. Just wait a minute. Okay. A game consists of spinning off round a stationary disk as shown below. When the arrow comes to rest. Okay. Here we have two disks, something like this. Here we have 2 discs like this. Okay, here we have disc like this. Now it is stated that when the arrow comes to rest, there are 8 equally likely outcomes. It could come to rest in any one of the sectors numbered 1 to 8 as shown. 2 such discs are used in a game where their arrows are independently spun. What is the probability that the sum of numbers on the resulting sectors upon spinning the 2 discs is equal to 8 after the arrow comes to rest? So getting any single number, the probability is 1 by 8, and here we have again 1 by 8, right? So this is equals to 1 by 64. Now what condition is given? The number should be equal to the number on both this disk should be equal to 8. That means the sum of the numbers should be equal to 8. That means the first pair is 1 7 2 6 3 5 4 4 5 3 6 2 and the 7 1. That means here we have 1 2 3 4 5 6 7. So here we have 7 pairs. That means the correct answer is 7 by 64. The correct answer is 7 by 64. Is it clear? Okay, that's all from my side. I guess I have covered all the questions which I have. So now let's discuss some other subject. Thank you.
Hello everyone. So now I am going to start a question from the digital electronics. Okay. From digital electronics, right now I have 4 to 5 questions. Okay. So maybe 5 number of question has been asked from the digital electronics, and all the questions I can say that was very easier question. Okay. So first question I am going to take. Going to take from the digital electronics. Okay, so question number one. First question is from a basic logic gate. So here 2 input is given. This is A and this is A bar. This A and A bar, and here the second input is B and this is B bar. Okay, so 2 input is given here. Now 2 number of here NOR gate is given, and output of both the NOR gate is connected with again one more NOR gate. Okay, now first NOR gate is connected with A bar and B bar. First NOR gate is connected here, A bar and B bar, and second NOR gate is connected with A and B bar, and this output function we have to find out. 4 options is also given here. I am going to write all the options. This is A plus B. Second option is this is A dot B bar. Third option is here A plus B bar, and the last option is given, this is B bar. So this is very easier question. Within 30 seconds easily we can handle this category of question. So here you can say, if you will see here, if you will remove this bubble, or if this is, you can say NOR, and again this bubble if you will remove from here, so this logic gate can be replaced by AND gate. This logic gate, this is a bubble NOR, and you can replace by the AND gate. So this is removed. So what you will get here, this is connected with A bar and B bar. So here A bar plus B bar, and here what we are getting, this is A plus from here this is B bar, and both are here doing AND. So what will the function F? Function F is nothing but A bar plus B bar dot A plus B bar. From NOR you can also process. So this is your choice. Okay, so just I am going to write here. So this A bar into A. So first term will be 0 plus second term A bar into B bar. Second term will be A bar B bar plus next term will be A dot B bar. And the last term will be B bar into B bar. This is B bar. If you can see here B bar is common. So here you will get, sir, 1 plus something, here you are getting A, and from the last term this is A bar. 1 plus anything is 1. So what is the answer? So sir, our answer is B bar. So this is very basic question. So answer is B bar. So you can also solve this question with different process. But if you don't want to play with this bubble, so this all the bubbles easily can be removed. This all the bubble easily can be removed. Okay. So this was very easier question. Now the second question I am going to take. Okay. Now another question from the digital electronics. So second question, question number 2. From the digital electronics. So here one resistor circuit is given, but they have mentioned this is a counter, but this is a practically resistor. So this 3-bit resistor is given. So this is first flip-flop, this is second flip-flop, and this is third flip-flop. And in resistor we can say same clock is provided, or you can say this is connected synchronously. So you can also say resistor is nothing but a synchronous counter. So this circuit is given, and this is your original clock, this is your input clock, and you can say here, sir, this is D0, this is Q0, this is D1, this is Q1, and this is D2, and this is your Q2. This output is connected to the next input. This output is connected to the next input. Now you know very well in resistor last 2 output is shifted for the shift right resistor. Okay, and only input, your first or you can say left flip-flop output can be modified. So here one NOR gate is connected here. Here one NOR gate is connected here, and this output is goes to the D0, and input of this NOR gate is nothing but one input is Q1 and second input is Q2. Second input is Q2. Okay, so this circuit is given, and here the question is the circuit work assay, the circuit act assay. So first option is given, this circuit act assay divide by 5 counter. So I can write, sir, divide by 5 counter, or you can say this is nothing but mod 5 counter. Option B is, sir, this is divide by 8 counter, and the third option is here divide by 7 counter, divide by 7 counter, and the last option is does not function as a counter, does not function as a counter, does not function as a counter, as a counter, does not function as a counter. So this 4 options given. So easily we can handle this question. Easily you can say, sir, this is shift resistor, but shift resistor you can also, that is nothing but mod n counter. So n is a number of output state. So here if initial I am going to write, sir, this is Q0, Q1 and Q2 initial. If you will write here initial, so initial we can assume all the output is 0. So after clock 1, so what we will get after clock 1? So always this two output, this and this output will be shifted to the next. So always this will be shifted here and this will be shifted here, and this 0 and 0 0 0 NOR. So 0 plus 0 bar is nothing but 1. So after first clock you will get 1 0 0. After second clock this 1 will shift here, this 0 will shift here. Now the Q0 will be 0 plus 0 complement. So this is nothing but 1. Then after third clock this is 1 1, and this is 1 plus 0, 1 plus 0 complement is this is 0. Now after fourth clock this is 0 1, this is 1 plus 1, 1 complement is 0. Now then after fifth clock, sir, this is 0 0 and 0 plus 1 is 1, 1 complement is 0. So now 0 0 0 is repeated here. So you can see here how many number of output state, 1 2 3 4 5. Now the 0 0 0 is repeated. So how many number of total output state? 5. So you can say, sir, this is nothing but mod 5 counter, and mod 5 counter is nothing but divide by 5 circuit. So this is nothing but divide by 5 counter. So this is nothing but divide by 5 counter, divide by 5 counter. This was very easier and very basic question. Okay, this was very easier and very basic question. Now come to the next question. Question number 3. Question number 3 from your digital electronics. Question number 3 from the digital electronics. So now the third question is, I am going to take third question from the ADC. So now here one ADC is given. In the third question ADC is given and resolution is given. Resolution is given. So resolution is given. Resolution they can provide in two way, either in percentage or in value or in voltage or in volt, and this is given 0.01 volt. You can also write the same value 1 upon 100 volt. Okay, now second value they have provided, this ADC converts analog signal between 0 volt to 10 volt, and here they have mentioned this convert analog signal between 0 volt to 10 volt, 0 volt to 10 volt, 0 volt to 10 volt, convert 0 volt to 10 volt. And now here what we can say, so here can I say, sir, this is nothing but full scale voltage. So full scale voltage I can write this is 10 volt. They have not mentioned full scale voltage. They have mentioned this convert, this is analog to digital converter. So converts analog signal between 0 volt to 10 volt. So full scale voltage is here 10 volt. And now the question is the minimum number of bits. The question is the minimum number of bits. The minimum number of bits we have to calculate in integer. Always number of bit is integer, but examiner are interested in here integer. So this is a numerical answer type question, we can say. So easily we can handle. We know the standard formula for resolution voltage. Here resolution voltage they have mentioned. This is resolution voltage. So what is the formula for resolution voltage? We know very well. Resolution is nothing but in terms of full scale voltage divided by 2 raised to power n minus 1. In terms of V reference, divided by 2 raised to power n. Here this resolution voltage is given, this is 1 upon 100. Full scale voltage is given, this is 10, divided by 2 raised to power n minus 1. So from here 2 raised to power n minus 1 is equal to, this is 1000. So from here 2 raised to power n is equal to 1001. So here what will be the n? So if you will consider here 9 bit, so for this 9 bit your resolution you will not get 0.01, you will get more than this, but I need at least this resolution or better than this. So always we have to consider here next integer always. So what will be the next integer? So here you will get approximate 9 point something. So nearest integer, next integer, not nearest, next integer always you have to consider. So this n is equal to 10. So here answer is n is equal to 10. So here you have to put in the box by, you can say in NAD box by your mouse you have to mention 1010. Okay, okay, sorry, this is not okay. So here n is equal to 10. N is equal to 10 because 2 raised to power 10 is 1024. 2 raised to power 10 is 1024. 2 raised to power 10 is 1024. Okay, so now the next question number 4. Now the next question number 4 I am going to take. Next question number 4 from the digital. Question number 4 from your digital. So here one question is asked from the multiplexer. One question is asked from the multiplexer, and one other stage of multiplexer is connected here. So two multiplexer is connected here. Here this is two input I0 and I1. I0 and I1 given. Here two input. This is I0 and I1 is given. Okay. Now here this is selections line S1. Here this is selections line. I can again write this S1. This input is V, and here this selection line input is A, and here this input is 1 0, and here this output Y, and this output Y is connected to here I1, and now this I0 is connected with 1, and the output is a Y. So we have to calculate, or you can say output is function. So this function we have to find out. This function we have to find out, and here 4 options they have provided. So first option is a plus b whole bar. Second option is a bar plus b bar. Third option is a dot b whole bar, and the last option is a bar dot b bar. And this is MSQ question. This is not MCQ. This is MSQ question. So this question is MSQ. So easily within 30 seconds we can handle. Here this is b bar multiply. So here you will get, sir, b bar multiply with 1 plus b multiply with 0. So second term is 0. So this is nothing but b bar. So now here you will get, sir, function f is equal to a bar multiply with I0. I0 is 1 plus now this is a, and a multiply with b bar. And now easily we can write this is a bar plus a, and in second bracket, sir, this is a bar plus b bar, and a bar plus a is 1. We know very well this is, sorry, a bar plus a is 1. This is a bar plus b bar. So the answer is a bar plus b bar, or we can also write this is nothing but a dot b whole bar. We can also write a dot b whole bar. So this is either a bar plus b bar or a dot b bar. So this is MSQ question. So here 2 options is correct. So again all the 4 question was very easier. One more question has been asked, but okay, we did not receive exact option. So from the option you can match. Okay, I am going to consider the question. Question number 5 from the digital. So in this question, examiner have provided a comparator, 2-bit comparator. So here they have provided 2-bit comparator, and in 2-bit comparator your first data is A1 and A0, and the second data is B1 and B0, and for suppose this is, you can say this is A, and you can say this is B. So for A is greater than B, if your function is 1, then what is the minimized form of this f? So minimized form of f. Okay, so this we have to, and 4 options in this question they have provided. A, B, C, D. Okay, so from options you can match. Answer I am going to find out. Here the important thing is minimize form of F. Examiner are interested in minimize form of F. So can I write, sir, this is A and this is a 2-bit comparator. Can I say, sir, circuit is 2-bit comparator? You can say this is A1, A0 and this is B1 and B0, and here output you have to find out for A greater than B. So this function will be 1 only for A greater than B. We can say this zeta is A and this zeta is B. So for this direct answer we know very well, everybody know. So how we can write, if A is 1 and B is 0, in another term if A and B is same, sorry, here we can say this is a MSB bit, this is 2-bit. So for 2-bit MSB bit I am considering A1 and B1. So if A1 is 1 and suppose B1 is 0, now in another way if A1 and B1 is same, so A1 XNOR B1, and if A0 is 1 and B0 is 0. But here examiner are interested in minimize form. This is very important thing. So first you have to find out, either from here you have to find out mean term. So our target is we have to find out this mean term. You have to find out this mean term. In another way you can write here truth table, and from truth table you can find out for which mean term A is greater than B. Okay, and we know very well here total number of condition is 6. This thing we know, total number of condition is 6. For A greater than B 6, for A less than B 6, and for A is equal to B 4. I hope everybody know this thing. So for 2-bit comparator, for greater than and less than, total condition is 16, 4 condition is for the equal to, remaining 12 condition, 6 for greater than and 6 for less than. So now suppose if I am going to write here truth table, so A1, A0, B1 and B0. Okay, so for A greater than B, so for A greater than B, or this function is F. So if this is 0, 0, 0, 0, okay, so this will be 0. For 0, 0, 0, 1, again this will be 0 because A is not greater than B. Now 0, 0, 1, 0, again this is 0. Now this is 0, 0, 1, 1, again this is 0. Now, so this is 0, 1, 0, 0, now this is 1, and this is 1 for the decimal value 4. Now, sir, this is 0, 1, 0, 1, now again this is 0, again this is 0. Now 0, 1, 1, 0, again this is 0. Now 0, 1 and 1, 1, again this is 0. Now the next value, sir, 1, 0, 0, 0, again this is 1, and now this is nothing but 8. Now 1, 0, 0, 1, again A is greater than B, again this is 1, and this is 9. Now 1, 0, 1, 0, so here this is equal, so this is 0. Now 1, 0, 1, 1, again this is 0. Okay, now the last condition, last 4 condition. Now, sir, this is 1, 1, 0, 0, again this is 1, 1, 1, 0, 1, again this is 1, 1, 1, 1, 0, again this is 1, and 1, 1, 1, 1, so both are same, so this is 0. So now this condition is 12, this is 13, and this is 14. So what is the mean term for A greater than B? So for A greater than B, our mean term is, so can I write here, so this function is nothing but, this is a mean term, sir, 4, 8, 9, 12, 13 and 14. 13 and 14. How many total conditions? 6 conditions. 6 condition means definitely this will be correct. So now we have to find out minimized term. So now we have to find out minimized form. So we can put this in the K map. So now we can put this in the K map. So now we can put this in the K map. But the important thing is which is MSB, which is LSB. Sir, this is A1, A0, and here this is B1, B0. Sir, this is 0, 0, 0, 1, 1, 0 and 1, 1. This is 0, 0, 0, 1 and 1, 0 and 1, 1. So now you can put the value here. Now you can put the value here. This is 0, 1, 2, 3. This is 4, 5, 6, 7. This is 8, 9. This is 10, 11. This is 12, 13, and this is 14. And this is 15. So now we can form the group here. Now we can form the group here. You can see this is the first group. So can I write the minimized form? This group we can write from here, sir, this is A1, and from here you can write, sir, this is B1 bar. So this is first term. This is first term, and this term is common in non-minimized form. Here this term is common, but this is not a minimized form. But this one is not a minimized form. So from here, which group we can form? So next group we can form here, sir, this 2 group we can form. So this 2 group, if you want to write here, so what we will get from here, sir, this is A1, A0, from here A1, A0, and from here this is B0 bar, and from here this is B0 bar, and now the last group, now the last group, this 2 1 group we can form. So what will be the answer? What will be the last group? So last group is nothing but, sir, plus here the common term is A0, here the common term is A0, and here B1 bar B0 bar, B1 bar B0 bar. So this is the correct answer, this is the correct answer. So from the 4 options we can match and we can take the correct answer. So in this question some twist has been created by the examiner. They have asked the minimized form of 2-bit magnitude comparator. Okay, so easily you can handle, just you to find out the minimized form in this question. Okay, so just I have concluded here 5 number of question from the digital electronics. Okay, from the digital electronics. Okay, and all the questions, according to me, all the question was very easier. All the question was very easier. Okay, now I am going to take some question from the signal and system. Okay, so 3 number of question I am going to take from the signal and system. Okay, so now I am going to take some question from the signal and system. So now I am going to take some question from the signal and system. So now question number 1. So first question, all the question was very easier question. So in first question, x of t is given, one signal is given, and this is t minus of 1 whole square, t minus of 1 whole square, u of t minus 1, and now here this Laplace transform is x of s. So here x of t Laplace transform is x of s, and now what is a value of x1? So capital X1 is equal to question mark. So here if you will calculate the Laplace transform, and you can put the value of s is equal to 1. Here 4 options is given, just I am going to write all the options. First option was e raised to power 2, second option was here 2e, third option was here 1 by e, and last option was 2 by e. Here 4 options is given. So now this was a very easy and basic question. This was a very easier and basic question. So we know very well Laplace transform of t ut 1 upon s square, Laplace transform of t square ut. So we know very well Laplace transform of ut is 1 by s, Laplace transform of t ut, this is 1 by s square, Laplace transform of t square ut. So this is nothing but 2 by sq. Okay, so we know very well Laplace transform of t square ut is 2 by sq. Okay, so now here we have to find out Laplace transform of t minus 1 square. So if I will put here the value t is equal to t minus 1, then what we can write here, sir? This will be t minus 1 square, and this you have to write, sir, this is ut minus 1. Then what will be this Laplace transform? So shifting property you can apply here. So what is the Laplace transform of this? So time shifting property we can apply here. Okay, time shifting property we can apply here. So what will be the answer here, sir? This is 2 by sq, and here e raised to power minus of s. So just you have to multiply by e raised to power minus s. But examiner are interested, and this value is given, this is nothing but sir x of s. Okay, this value is nothing but x of s. So I can write, sir, this value is nothing but x of s, and we have to calculate here value of x1. We have to calculate here value of x1. So what will be the x1? So x1 will be, sir, 2 by you can put this is 1 raised to power q will be 1, and e raised to power minus of 1, e raised to power minus of 1. So option is 2 by e is given. So we can write this is 1. So this is 2 by e. So our answer is 2 by e. This is very basic and very easier question. So here the answer is 2 by e. Okay, so now I am going to take another question. Another question from signal and system. Now the question number 2. Question number 2 from the signal and system. Okay, so now another question I am going to take. Okay, now another question I am going to take. Now here in second question, y of t, one relation between input and output of the system is given. Here y is given, x of t multiplied by sine 2 pi by sine 2 pi t. This thing is given. So this, what is, sir, yt and xt? Input of any system is xt and output of any system is yt, and this relation is given between input and output of the system. Okay, now examiner are saying which is the correct correct options, okay, for the relation between xt and yt. So the system is, so exactly they are asking the system is linear, non-linear, causal, non-causal, this kind of option they have provided. So here in the option they have asked linear, non-linear, time variant and time invariant. So first option is non-linear and time variant. This is the first option. In second option again this is linear and time variant, and in the third option this is non-linear and time invariant, and the last option is given linear and time invariant. So now you can see here, sir, how we can handle this kind of question. This is your input xt. So input is not given in terms of square or another delayed version of input, or another version of input is not multiplied here. It means this is 100% linear. So it means sir, this is 100% linear. And now you can see, if any time function is multiplied, if any time function is multiplied in the input, then definitely this is a time variant. So directly from the basics we can handle this question. So directly from the system basics, so here linear and time variant. So here the option is, so answer is option B. So here answer is option B. One more question, again that was very easier question. Again that is very easier question. So now the question number 3 from the signal and system. So question number 3 is given, one differential equation is given. So here d by dt, one relation is given, d by dt y of t, d by dt y of t plus y of t is equal to 3 of x t minus 3 and u of t minus 3. So this input output relation is given. So here examiner are asking transfer function of the system is, again this is very basic question. From the Laplace transform we can handle. Here 4 options is given. First option is e raised to power minus s by 3 divided by s plus 3. Second option was given 3 e raised to power minus of s by 3 divided by s plus 1. Third option is given e raised to power minus 3s divided by s plus 1, and the last option was given 3 e raised to power minus of 3s divided by s plus 1. So how we can handle this question? So just you can apply the Laplace transform. So what is the Laplace transform of this? Sir, this is s into ys plus, sir, this is ys is equal to, sometime student can be trapped here. Sir, what is the Laplace transform? So do not worry, 3x xt minus 3 ut minus 3. Okay, so what is the Laplace transform of this? So directly you can write, sir, this is magnitude is 3, xt Laplace transform is xs, and this is a shifted version. This is shifted version of xt. Suppose if, sir, xt ut Laplace transform is xs, then sir xt minus here 3, again you will be always shifted, this Laplace transform will be. So xt Laplace transform is xs, and this is shifted version, so e raised to power minus of 3s. So same you will get, sir, here e raised to power minus of 3s. One important thing you should remember, if the system is given, so definitely this should be LTI system. That's why only we can calculate the transfer function. Always we calculate for the LTI system. So you do not worry, sir, if I will apply here a differentiation property, so in initial value initial condition we have to consider or not? No, initial value will not be considered in any system, because for non-LTI system you cannot find out transfer function. So if examiner are interested in transfer function, so this is understood, we have to calculate and we have to calculate transfer. If they are asking calculate the transfer function, so this is understood, we don't have to consider initial value. Okay, so just what will be the answer? So ys by xs we have to find out. So this is ys, this is s plus 1 is equal to this is 3 e raised to power minus 3s into xs. So what will be, sir? Ys by xs is nothing but transfer function. You can write this is nothing but transfer function hs, and you can write, sir, this is a transfer function of LTI system. So is equal to 3 e raised to power minus 3s upon s plus 1. This is the answer. So you can match the option 3 e raised to power minus 3s upon s plus 1. So option D is the correct answer. Option D is the correct answer. Again, this question was very easier question. Again, this question was very easier question. So just right now I have conducted 5 questions from the digital and 3 questions from the signal and system. Okay, so now I am going to stop my session right now. Now next session will be conducted for the communication system within a minutes. Okay, so enjoy the session. Thank you and take care.
हाँ अरे एकदम hello everyone and good evening to all of you. So we are now going to discuss about the communication question of in instrumentation paper. Okay, so today we have seen only 3 questions on instrumentation, and all 3 questions are very easy. Okay, very easy question. So now start from the very first question. This question is asked in the gate 2022 of instrumentation paper. Okay, so I am taking the very first question. This first question is here. This is the very first question. What is this? Okay, this is the basic question, basically from the communication system, or it is basically from the analog communication. Okay, so tell me, my voice is clear to all of you? I think level of paper is easy. Yeah, definitely the level of paper easy. So according to the question from the communication, it is very easy. One of the question is moderate level, otherwise the 2 question out of 3 is very easy. Okay, so one of this question is the very easy question. If you know about the Fourier spectrum of the signal, okay, then you can solve this question easily. Okay, so just read it down. So the signal xt is band limited between the 100 Hz and 200 Hz. So it is the band limited between 100 Hz and 200 Hz. Okay, so this is 100 Hz and 200 Hz. So xt is the band limited. So just draw the one spectrum of xt like this. This is the f axis. Okay, so I am taking this is the spectrum of xt, x of f. So it is the band limited between 100 Hz and 200 Hz. So this is the 100 and 200 like this. So its bandwidth is from 100 Hz to 200 Hz. Okay, so this is the bandwidth, or we can say this is the band limited signal xf, xt band limited between 100 and 200 Hz. So this is the spectrum of xt. I am taking the spectrum of xt like this. Okay, I don't know the shape of the signal, but I am just taking the considering the rectangular type of signal. Many of the textbook taking is the triangular type. So I am just taking the rectangular type. Now what the examiner is saying, it is saying a signal by t is related to xt as follows. So by t is related by xt is like this. It means if you think about this, okay, so this is the by t equal to x of 2t minus 5. Okay, Now how to get the by t from xt? By giving a shifting, okay, by giving a time shifting 5 times, and there is one scaling in x. So this is the scaling property, okay, scaling of the signal. Then we will get the by t. So first we take shifting. If you go through this side from this side, okay, so this is the shifting, after that scaling, and especially it is the compression, it is the compression, okay, compression. So if you perform the compression in time domain, then what will be the effect in frequency domain? It is the expansion. So now your spectrum is going to be the extend by a factor of 2, okay. So now the spectrum of by f is the spectrum of by f is so the spectrum, voice is not coming, voice is coming, proper coming now, okay, voice is coming. So voice is proper from our side. You just take your phone and see it. So the spectrum of by f is, sir, it is from multiplied just by a 2 factor of 2. So this is the 200 hertz and this will be a 400 hertz, okay, 400 hertz. This is like this. So this is the spectrum of by f, okay. There is no effect of the shifting, but the effect of scaling is always on the spectrum of the signal. So we will get the by t by compressing the x, and we will get the spectrum of by just expanding the x. So this is the actual spectrum of the signal by t, okay. Now what is the option, sir? Option, this is the band limited, this is the band limited signal. So by t is band limited. So option B is wrong, because he is saying by t is not band limited, and by t is band limited between 200 hertz to 400 hertz, okay. So the option A is correct, because it is band limited between 200 to 400, okay. So by t is band limited between 50 to 100, no. It is band limited between 100 and 200, no. So the correct option of this question is A. It's a very simple question, very simple question. If you know about the scaling and the effect of scaling in time domain, then what will be the result in the frequency domain, okay. So the correct answer of this question is A, a very simple question. It's a very simple question, okay. So now moving towards the next question. So moving towards the next question, I am taking the second one like this, okay. It's a very simple question. I think I am not sure about the marks, if it is in 1 marks or 2 marks, whatever may be, okay, but it will provide you with a free marks. This is just a free marks question, okay. It's a very simple question. If you know about the basic of amplitude modulation, then it's just a lollipop type of question, okay. So just see whatever he is saying, it's just a time pass. If you see carefully, then it is nothing but a amplitude modulation. It is the amplitude modulation equation, okay, amplitude modulation equation, okay. So this is the standard amplitude modulation equation. He's asking about, he just want message signal recovery, okay, the message signal that can be retrieved completely, okay, especially by the envelope detection, okay, envelope detection. So examiner wants the message signal, recover the message signal with the help of envelope detection. So what is the condition of envelope detection is the modulation index is less than 1, okay, the modulation index is less than 1. So modulation index is less than 1, it means what? If you just put the value of mt in this equation, then you just see this value behave like a modulation index, okay, this value behave like a modulation index. You just put it 1 by 1, okay, just put it 1 by 1, then you just see only option C, having the mu is less than 1, having the mu is less than 1, okay, remaining have the mu is greater than 1. So only C option is correct, C option is correct, okay. Just a 30-second question, 30-second question, 30 seconds, it will take only 30 seconds, nothing else, okay. So simple question, you just take it out, 30 mu is less than 1, this only option C is satisfied. So I don't know whether it is the 1 marks or 2 marks. If it is the 1 marks, or whether it is in 2 marks, it is the free marks. You just take it out. Okay, so the correct option of this question is C. Okay, so very simple question is asked from the communication system. So 2 question I have already done. So the remaining one is here. So I am just showing you the last one question. You just see, it's a very simple question. It is based on the bit rate. Okay, bit rate by the time division multiplexing. So it is the bit rate. This question is from bit rate. So I am just taking this question. You just see. Okay, see this question. What they are saying. It's a very simple formula based question. So consider a 24 voice signal. There is a 24 voice signal. It behaves as a 24 channels being transmitted without latency. Latency means delay. Okay, using TDM. Okay, if signal is sampled at 12 kilohertz, then represented by a 8-bit bird. He is asking about the bit duration. Generally examiner is asking about the bit rate. Okay, so don't confuse about the bit duration and bit rate. Simply it's a bit duration. Here examiner is asking about the bit duration, not a bit rate. Okay, so first you have to calculate the bit rate. So bit rate is what? It is nothing but equal to, just multiply the number of signals. Okay, how many bits is used in a one bird? It 8-bit. So multiplied by the 8. So it is the total number of bits. And if you multiply it with sampling rate, then you will get the total bit rate. So sampling rate is 12 kilohertz. Okay, so just take it out. It is nothing but equal to, if you calculate it, it is nothing but equal to 2304, approximately 2304 kbps. Okay, kbps. If you taken it out in mbps, then it will be a 2.304 mbps. Simple. Okay, it is the RB equal to 2304. It's not an answer. Okay, just wait. It's not an answer. Just wait. It's not an answer. So it's a RB. Okay, it's a RB. It's not an answer. He's asking about the bit duration in microsecond. Okay, bit duration. So bit duration is nothing but equal to TB. So TB is nothing but equal to 1 by RB. So just take it out. 1 by RB. It is 1 upon 2.304 into 10 to the power 6. It is the Mbps. Okay, so the value of TB is 1 upon 2.304 in microsecond. Okay, in microsecond. 10 to the power 6 is come out from this lower side to upper side, then it will be a 10 to the power minus 6. And examiner is also asking about in microsecond. Okay, so you just have to calculate this 1 upon 2.304. Okay, then you will get the correct answer. So this part is from your side. Okay, this part. So you just calculate it. So what may be the calculation, and it will be your answer. So just put it down. So it's a very simple question. Very simple question. If you know about the formula of bit rate, okay, under TDM, then you will get the bit duration. So here I think in this question there is one keyword that is called bit duration. This is the keyword. Okay, bit duration. Generally examiner asks about the bit rate. Okay, someone is filling like this 2.304 because it is also a mega. Okay, if you confuse about the microsecond and mega, okay, if you confuse about, if you read it as a mega, then your answer is this 2.304. Okay, 2.304, but actual answer is 1 upon 2.304. So you will get the correct answer. Got it? So you will get the correct answer. Okay, so this is the 3 question is asking from the communication system. Okay, so you just leave your comment what was your paper and how many marks you can expect it according to mine. According to from my side, it's a very easy, or easy not, it's a moderate paper. Okay, not a very high level paper, it's a moderate paper. Then you will get, definitely you can score in this paper well. Okay, so don't take any pressure. You just keep and calm and wait for the result, because you will get the, definitely you will get the some rank. Okay, so bye bye from my side and good luck to you, all of you. Okay, so the session on other subject will definitely come on this channel. Okay, so take your rest and wait for the result. Okay, bye bye.
Hello everyone. So now I got some question from the network theory. So just 2 questions I am going to take right now for the network theory. Okay, so be ready. So the next question from the network theory. Okay, from the network theory I am going to take the question from the network theory. Okay, so first question, question number 1. Question number 1. So in the first question, one LCR circuit is given. Okay, so in the first question, here this is L, here this is R, C, and here this is R is given. So you can say this is series RLC circuit, but in general we calculate output across the capacitor. That is for the low pass filter, but this is not a low pass filter. They are asking the output across resistor. So this is given. The mention is this is R0, this is C0, and this is L0, and this is the input. This is the input, and this is the output. Okay, so this circuit is given. You can say this is series RLC circuit, but they are not mentioned. They have mentioned this is one kind of filter. Okay, this is a filter, but this is a basic standard series RLC circuit. Here value of R0 is given. R0 is 50 ohm, and the next L0 or you can say inductor value is 1 millihenry, and the next one is capacitor. Capacitor value is given. This is 10 nanofarad. This is 10 nanofarad, and quality factor we have to calculate. Quality factor Q is equal to question mark. Very easy and very basic question. Direct by formula easily we can handle this question. So this is a standard series RLC circuit. Don't be confused, sir. Here RLC will be. This is basic standard series RLC circuit. So what is the quality factor of series RLC circuit? 1 by R root over L by C. RLC value is given. You can also use omega 0 L by R. You can also use 1 upon omega 0 RC. Okay. We know this formula omega 0 L by R, 1 upon omega 0 RC. Okay. Many formula we know. Okay, but here RLC value is given, so we can go with this. So here quality factor is nothing but 1 by 50 root over L is given here 1 milli. So 1 into 10 raised to power minus 3 divided by 10 nano, 10 into 10 raised to power minus 9, 10 into 10 raised to power minus 9. So here what we will get, Q is equal to 1 by 50. This is root over. This is 10 to the 6 minus 10 to the minus 3, 10 to the 9 minus 10 minus 3. This is 10 to the 6 by 10. So we can also write this is 1 by 50 root over 10 raised to power 5. This is 10 raised to power 5. So if we will calculate, so approximate we are getting 6 point, this quality factor we are getting 6.3324. This is 6.324. This is the answer. If our data is correct, so the answer is 6.324. 6.324. This is the quality factor. This is the quality factor. This is the quality factor. Okay. Now one more question I am going to take. Okay. Maybe I don't have exact data, but concept I will tell you. Calculation you can easily you can do by yourself. Okay. Now one another question. Question number 2. Question number 2. And in this circuit, this is a supply is given, and supply is 100 at angle 0 degree, 100 at angle 0 degree. Here one resistor and one capacitor are connected in parallel, and one more inductor and one resistor are connected in series. So you can say one RL and RC, one RL are connected in series, and RC parallel circuit and RL series are connected in series. Okay. Now this is given C1, and C1 is given 100 by pi. Okay, 100 by pi, and this is microfarad, and from here, sir, this R1 is equal to 20 ohm, and here this inductance value is L1. This L1 is given. This is 20 by pi millihenry. Okay, and you can say, sir, this is RL, and RL is given 4 ohm. Okay, so this circuit is given, and in this question, omega is also given here. Frequency is 50 hertz. This thing is given, and now the question is what is the supply power factor or input power factor? The question is what is input power factor, or you can say supply power factor. This thing you have to calculate. So what is input power factor of the whole circuit? Is nothing but, I can say, sir, supply power factor or input power factor is nothing but cos phi, and cos phi is nothing but cos phi. And what is the phi here? So this is a phi, I can say, for the total supply power factor. So phi s is nothing but impedance angle of z. We know this thing, angle of z. So if you will calculate angle of z here, so cos phi easily we can calculate, easily we can calculate. So now, so just you to calculate impedance of this, and from that you have to calculate angle of impedance. So first, if I am going to write impedance, so first you can solve this block parallel combination. What you will get, sir, R1 into 1 upon C1s divided by R1 plus 1 by C1s. So if you will solve this, so what we will get, sir, R1 upon 1 plus R1 C1 into S, R1 upon 1 plus R1 C1s. So if we can put the value here, so R1 value is, R1 is your 20 divided by 1 plus, what is R1 into C1? So R1 is 20, C1 is 100 by pi, micro, 100 by pi, this is micro. Sorry, okay, 100 by pi micro. And now what is C? I can write J 2 pi f. So sir, this is J into 2 pi into 50. Can I write? Okay, so from here what we will get, sir, from 20, this is 21 plus J. So here what you will get, so you can say, sir, this pi and this pi will be cancelled out. This pi and pi will be cancelled out. So from here, sir, this is 100, and this is 50 into 200. So this is J. Can I write 20 into, here this is 100, here this is 100, 100 into 100 into 10 raised to power minus 6, like this. Okay, calculation you can check here. So from 20, from here this is 21 plus J. So this is 1, 2, 3, 4, 5, 0 if you will cancel. So only you will get 1 by 10. So here J 2 by 10. So here what we can get, so from here we are getting, so 20 upon 1 plus J. This is 2 by 10 is 1 by 5. 1 by 5 means 0.2. So this impedance you are getting 20 upon 1 plus J 0.2. Similarly, so what will be the Z here? So what will the Z of the whole circuit? This RL plus L1. So can I write 4 plus, this is J omega L. So this is J omega, and omega we can write, sir, 2 pi. So 2 pi into F. F is 50. This is J omega, and what is L is here? This is 20 by pi milli. Milli means 10 raised to power minus 3. Okay, and now plus this impedance, and this impedance is plus 20 upon 1 plus J 0.2. So now, sir, what is Z? Z of the circuit, 4 plus, from here, any value will be cancelled out. Sir, this pi and pi will be cancelled out. 50 into 200, 50 into 200, 100 into 20. 100 into 20, that is 2000. So from here you will get a, sir, Z2. So from here only we will get, this is only Z2 plus this is 20 by 1 plus J 0.2. So from here we will get, sir, Z is equal to 4 plus J2 plus from here 20 into 1 plus J 0.2 divided by 1 square plus 0.2 square. So this 0.2 square, this value will be very small value. So exact value you can calculate, approximate value I am going to calculate. So sir, this is 4 plus J2 plus, so this I am going to neglect because with respect to 1 this will be very small, and this is in denominator, so it will not be affected. So from here, sir, this is 20 plus J, 20 into, you can write, sir, this is 2 by 10. So here this is J4. So what we are getting, Z is equal to 4 plus J2 plus 20 plus this is J4. So from here we are getting 4 plus 20, 24 plus this is J6, 24 plus J6. So this is Z. So from here angle of Z. So angle of Z will be nothing but tan inverse, imaginary by real. So 6 by 24. So from here angle of Z. So angle of Z we are getting tan inverse 6 by 24 means tan inverse 1 upon 4. Okay, so this answer you can calculate. Okay, this answer you can calculate. So angle of Z. So what is a power factor? So input power factor. or supply power factor, from here you will get cos phi, or you can say cos phi s, and this is nothing but phi s. This is nothing but phi s. This is nothing but phi s. So from here you will get answer cos phi s. So first you can calculate phi s. Okay, now I am going to calculate. You can also calculate. You can also calculate and tell me the answer. You can also calculate and tell me the answer. So here this is 1 by 4 means 0.25. 0.25. This is 0.25. Okay, this is 0.25. But tan inverse. So tan inverse 0.25. We are getting here 14.03. We are getting 14.03. Again, I am going to check one more time. 1 divided by 4. This is 0.25. Tan inverse is 14.03, and cos of this, okay, cos of this you can find out. Okay, so just calculation you can do, okay, calculation you can do. So in this question, examiner are interested in input power factor or supply power factor. So what we have to do here in this question, we have to calculate here impedance angle, and we know this thing, impedance angle and supply power factor. Angle both are same. Okay, so just I have concluded here 2 questions from the network theory. Okay, so this calculation you can do and you can match your exact answer. Okay, now okay, I think there are some data mismatch in the question or something. Okay, because maybe answer we are getting 0.97, but answer okay, it can be. Okay, so now I am going to end my this session from my side. Okay, so now very soon, within a minute, next session will start. Okay, thank you and take care.
स्टार्ट कर दिया मैंने. हेलो. यस. Good evening to everyone. How are you? I hope all of you have written excellent paper in the instrumentation stream. Okay, so let us see what are the questions we got from the instrumentation. Good number of questions we got from the instrumentation. So एक बार session को like कर दीजिए. So please like all of you this session. 8 people are watching. So let us see some questions which came from the instrumentation paper. Let us start from the beginning. 3 subjects है. Sensors, optical, measurements. So this question from network theory, this is also network theory, mass, controls, analog, mass, controls, analog, mass, measurement. Yeah, यह एक measurement का question है. Question number 11 है, measurements का question है. So let us see this question. Let me clear off this board. Just go through. The paper was excellent with respect to measurement subject and with respect to instrumentation also. It's a very good paper. We got it. Okay, so let us see the width of this paper and what are the questions we got it. Yes. Let us start with first a measurements question. So this is the measurement question. So we got this as the measurement question. So this was a star model. Topic is related to what? Star model, capacitive, leading power factor. Okay. So in a balanced 3-phase circuit shown, C0 is 8.2 microfarads and the line to line RMS voltage is 440 volts. So this is the R, this is the Y, and this is the B sequence, RYB sequence. The reading on the wattmeter is dash. That was the question. So first let me take this as a star model. So let us take a star model diagram like this. So this is a star model. So this is the RYB sequence. So from this we are getting the current, and this is our Y, sorry, this is our Y. So here comes our potential coil, and this is our B generally. Okay, so this is the B and this is our Y. So this is our Y and this is our R. So from this is getting the current coil like this. So this is a current coil, current is passing here, and this is the Y sequence, and the potential coil is connected between these two. He has very clearly given the potential coil is connected between these two. So we can take this the potential coil, and the line voltage he has given this the VRY, and this is a capacitive load. So we can take it as a ZPH, capacitive load, ZPH and ZPH, and the current passing through this is the line current and the phase currents both are same. So we have to keep a point now. This is the star network. So for a star model, what is the sequence? For a star model, the VL will be equal to √3 times of VPH, and IL and IPH both are equal, my dear. So now first of all, if you see this diagram, so what is the wattmeter reading now? So the wattmeter reading is nothing but always voltage of the potential coil, current of the current coil, and the cosine angle between this VPC and ICC, my dear. VPC and ICC. So potential coil is nothing but VRY. So this voltage I can take it as VRY. ICC I can take it as IR, and this is cosine VRY and IR. So let me talk about this VRY. This VRY is nothing but the line voltage. IR is nothing but the line current, and cosine IR and whatever this current coil, line current and phase current both are same. So we can take the angle between the VRY and IR. So let me draw the phasor diagram first. So how to draw the phasor diagram? So this is the phasor diagram. So this is a VRN. So this is the Vyn and this is the Vbn. Okay, my dear. So this is the Vrn and this is our Vyn and this is our Vbn, my dear. Vrn, Vyn, Vbn. Yes, Prashant. Hello, how are you, man? Prashant Reddy. Are you following? How did you write the paper, instrumentation paper? So this is a Vrn, Vyn, Vbn. It's a capacitive load. For a capacitive load, the phase current leads by phi. So this is our IRN, yes or not, my dear? And this is going to be leading. So this is our IYN and this is going to be leading. So this is our IBN, my dear. So if I am taking this as IRN, now this is the angle phi. So first of all, what I need what, my dear? I need VRY. I need VRY. So VRY kaisa likh sakte hai? So VRY can be taken as Vrn minus Vyn. Am I right or not? VRY can be taken as Vrn minus Vyn. So this is Vyn. Usko negative side expand kar dijiye. So we are going to get it as minus, sorry. So if you take this one to the negative side, so we are going to get this as minus Vyn, minus Vyn. So now the resultant of this Vrn and Vyn, we have to take it. So if you take the resultant of these two, what I am going to get? Vrn minus Vyn. So if you take this resultant, so this resultant is nothing but Vry. Kya hai resultant? So this resultant is Vry. Okay. Without phasor diagram concept, you cannot solve this problem. Now I want the angle between these two. So this is the resultant angle. Why? Because this is a phase current. So this is the phase current, this is the line current. Both are same. Okay na? So this is the line voltage. Vry is the line voltage. That's it. Now what is this angle? If you check, the angle between Vbn and Vrn is 120. So this cuts as 60, 60. So this total is 60. Again, this green color cuts it as 30, 30. So this total is 30 and this is 5. That means this angle will be 30 minus 5. So the angle between Vry and IR is coming as 30 minus 5, my dear. How much it is coming? 30 minus 5. All of you are following? Yes, dear. How many of you are there? Please like the session. We know comparatively global, compared to main channel, here strength will be less. South Indian students are watching. I know everybody. I know all of you. Please like the session here. Share the session. I am expecting more likes and more things from you. कैसे हो? Yes. चलो 30 minus 5 आ गया ना? Yes. So this one Vry in IR, the angle we got is 5, 30 minus 5. So now if I am substituting here, so wattmeter reading kya hoga? The wattmeter reading is equal to the line voltage and the line current cosine 30 minus 5 ho jayega. So let us solve phi first of all, impedance angle. So to get that phi, what I can take, if you see, I need the phi impedance angle means I need VPH and ZPH. So if you need the impedance angle of ZPH, that is the VPH and IPH. So first of all मुझे IPH चाहिए. So first of all मुझे VPH चाहिए. So in the given question, VL is given. VL is equal to 440 volts. So we know for a star model, VL is equal to root 3 into VPH. So VPH can be taken as VL by root 3. So इसका answer होगा 440 by root 3 होगा. So this is the VPH, my dear. Next comes the IPH. IPH is equal to IL, but we don't know that. We have to calculate. How to calculate it? That you can calculate from the ZPH. ZPH is equal to 1 by J omega C. That means minus J by omega C, my dear. So now if you see the angle, so that means ZPH can be taken as 0 plus 1 by omega C, 1 by omega C into minus J. This is in the form of A plus JB. So first of all, what is the magnitude of ZPH? If you see the magnitude of ZPH, square root of A square plus B square, that is 1 by omega C whole square. That means we are going to get the value as 1 by omega c. If you simplify, how much it is going to be? ZPH ka value, that is 2 into 3.14 into 50 hertz into capacitance. I think he has given 8.0 na. In the question, what is the capacitance value, my dear? In the question, capacitance value is given as 8.2 microfarads. Question is given as 8.2 microfarads. So this one you can take it as 8.2 into 10 to the power of minus 6. So how much you are going to get this one? So if you check now, 2 into 3.14 into 50, 8.2 into 10 power minus 6. So 1 divided by answer, if you do, I am getting exactly 388.4 ohms. So this is our ZPH. But what about the angle, my dear? If you see the angle, the real part is 0. So the real part is 0 means the phase angle I can take it as 90 degrees, my dear. Okay, the phase angle I am going to get as 90 degrees. So now if I am substituting all these things, what I need, line current I need. So we got the ZPH. So first of all you can get the IPH. So what is the IPH? IPH I can take it as VPH by ZPH na. Yes. What is the VPH, my dear? VPH is 440 by root 3. This is 440 by root 3. And what is the ZPH? ZPH is 388.4. So how much you are going to get? You can check it. So 388.4 into root 3, 440 divided by answer, it is coming as 0.654 amperes. 0.654 amperes aa raha hai. So this is the IPH. IL is equal to IPH. So we got IL, we got phi, and we got already VL. We got already as VL. So now if you substitute all these things, you are going to get the answer. So VL is already 440, IL is already 0.654, and cosine 30 minus 90 degrees. Why? Because pure capacitive load, for a pure capacitor load, the current leads the voltage by 90 degrees, my dear. Got it? So 30 minus 90 cos 60. So that is coming as 1 by 2. So this is the 0.654. So this is a 1 by 2, my dear. So if you simplify, how much you are going to get, my dear? Into 1 divided by 2 into 440. So you are going to get as 143 RI na. So we are getting it as 143.89 watts. Please don't round off the things, my dear. If you round off the things, it is going to be coming different. Okay. Please don't round off the things. Cos 61 by 2, correct? If I take 0.6, it is coming different. Okay. If I am taking the 0.6, it is coming different. I think 440 into, oh my god, lot of difference is there. If you take 0.654, it is different. Okay. So in main channel I did a mistake, I think so. 143.810 RI. Is it right? Anybody? Any corrections? Please tell me here. Anybody, any corrections? Please tell me. Anybody, any corrections? Please tell me. Yes. So 143.89 watts are 143.89 watts. So please be careful about the calculations, don't make a mistake. I think in the main channel I have taken it as round off to 0.6, that is a point I have done a mistake. Okay, so don't round off the things here. So things are changing. 0.6 अलग है, 0.65 अलग है, 144 watts आ रहा है. Okay, so the right answer is 144 watts. 12 watts difference आ रहा है. Let us go for the next question, my dear. So next question is from analog. This is networks. Yeah, if you see this question, what is the purpose of this question number 16? This question is related to sensors. But is it a MSQ or MCQ? I am not understanding. I think it is a MCQ only. A pneumatical nozzle flapper system, that is a flapper nozzle system, is conventionally used to convert small changes in the flapper's displacement to large changes in the output temperature. This is nowhere related to temperature first of all. So temperature क्या क्या options है वो eliminate कर दो. First, please eliminate the temperature options. Hello sir, I simply made by V square by Z. Option B आ रहा है. Yes, gate villa. Previous question, don't make the simple answers here. I think you will get the correct answer with this method. If you checked it, you are going to get it as 144 watts. You are going to get as 144 watts. Yes, it is related to displacement and pressure. Okay, that means you can say small changes in flappers displacement to large changes in output pressure, small changes in velocity. This is nowhere related to velocity. So the right answer is option B is the right answer. Option B is the right answer. Chalo my dear, let us go for one more question. So this question is asked in the measurements. So let us solve this question also. Measurements पर बहुत सारा questions आ गया. So question number 18. So if you see this question, measurements का, so you are going to get, what is this question? This question is related to, I think it is related to Maxwell inductance bridge. Bridge shown in the figure is balanced. R1 is given, R2 is given, C2 is given, 2 kHz sine wave is given, the value of L3. So how to solve this question? Okay, so first let me draw this diagram. Let me draw this diagram as a branch. So if you take this as first branch like this, so this is a first branch, and next one is the second branch like this, and here comes a capacitor. Okay, and the third branch is inductance and resistance. Actually ये हमारा Maxwell inductance bridge का diagram है ना. I think you can take this as Maxwell inductance bridge, inductance capacitance bridge. Actually this should be in the first branch and it should be in the last branch, just he has exchanged the terminals. Yeah, and this one he has taken as R4. So this one he has taken as R4. It is nothing but a Maxwell inductance capacitance bridge. So this is R1, so this is R2, this is C2. And what is the supply he has given? Supply is given between these terminals R1, R2 coming in series. So that means this is the supply. The supply is coming like this. Very good question. So question is related to Maxwell inductance capacitance bridge, my dear. Question is related to Maxwell inductance capacitance bridge. यही ना, ये क्वेश्चन क्या है? मैक्सवेल इंडक्टेंस कैपेसिटेंस ब्रिज. वेरी गुड, वेरी गुड, परफेक्ट परफेक्ट. मैक्सवेल इंडक्टेंस कैपेसिटेंस ब्रिज है. एक्चुअली ये टेस्ट ब्रांच जो कुछ है ना, दैट शुड बी इन द फर्स्ट आर्म एंड दिस शुड बी इन द लास्ट ब्रांच. जनरली हमारा गेट एग्जाम में क्या होता है, गेट एग्जाम में वो एक्सचेंज कर देता है. गेट एग्जाम में कंफ्यूज करने के लिए हमको एक्सचेंज करता है. सो ब्रिज शोन इज बैलेंस व्हेन R1 is 100 ohms. So this is 100 ohms, my dear. This is 100 ohms and R2 is 10 ohms. R2 is, this is 10 ohms. And next, what is C2? The C2 is 2.9 microfarads. So this is 2.9 microfarads. Next, R4 is 50 ohms. Yes, R4, this is what, 50 ohms. Next, the 2 kilohertz sine wave, the is applied. So frequency is 2 kilohertz is applied. The voltage is 10 volts. The voltage is 10 volts. And L3 is the question. But what about R3? I think he has not given R3. R1, R2, R4 information is given, but R3 information is not given. So kaisa karna hai? So we have to take everything in order. So Z1 is equal to R1. So that is equal to 100 ohms, my dear. We can take like this. Next, Z2 is R2 parallel to 1 by j omega C2. So this will be R2 by 1 plus j omega R2 C2 hoga. R2 into 1 by j omega C2 by R2 plus 1 by j omega C2. We simplify, you will get this. Okay. So if you want, you can make it a simplification. R2 how much here? R2 is 10 ohms. R2 is equal to 10 ohms by 1 plus j. Omega is 2 pi f. And R2 he has given, right? Sorry, C2. C2 has given us 2.9 microfarads. So this is given as 2.9 microfarads. So let me simplify. 10 by 1 plus j, 2 into 3.14 into frequency is given as how much, my dear? 2 kilohertz. So 2 into 10 power 3 into 2 pi f na. So into 2.9 into 10 to the power of minus 6 karna hai. So if you simplify, how much you are going to get? Please make the calculation part clear. 2 into 3.14 into 2 into 2.9 into 10 power minus 3. So it is coming as this much. So this will be what, my dear? So 10 by 1 plus 0.0364 JRI. So this is the Z2, my dear. Okay. So this is Z2. Next, what about Z3? Z3 is nothing but R3 plus j omega L3. So R3 information we don't know. Next, Z4 is equal to R4, that is equal to 50 ohms, my dear. So what is the balance condition? So if you see this one, I can write it as Z1 Z4 is equal to Z2 Z3. So Z1 is given as 100. So this is given as 100, and Z4 is this, that is given as 50. This is given as 50, and Z2 is this 10 by 1 plus something, 10 by 1 plus of 0.0364 j, 0.0364 into j into Z3. What is Z3? So this is the Z3. Z3 is R3, we don't know. R3 is also not given, na? Omega 2, oh my god, 2 into 3.14, 2 pi, 2 kilohertz, 2 into 10 power 3 into L. So it's coming lengthy, right? 2 into 3.14 into 2 into 1000, 12,560. L we don't know, 12,560 L divided by 1 plus 0.0364 into J is equal to 5,000. So now if you compare this 5,000 into 1 plus J 0.0364, you compare this with R3 plus J 12,560 L. So how much you are going to get? So this is 5,000 plus J, 5,000 into 0.0364 is equal to R3 plus J 12,560 into L. So comparison, R3 you are going to get 5 kilo ohms and 5000 into 0.0364 is equal to 12,560 L. So L will be 5000 into 0.0364 divided by 12,560. Am I right? So how much you are getting? 5000 into 0.0364 divided by 12,560. It is coming as 0.0144, 0.01449. That means 0.0145 Henries. So that means I can write it as 14.5 millihenries coming. So am I right? So the right answer is 14.5 millihenries coming. Am I right or not? Is it right? Mr. Gatevilla, is it right? 14.5 millihenries coming? It's coming around 14.5 millihenry. 14.5 millihenry aa raha hai. Okay, chalo, let us go for the next question. So if you go for the next question, yeah, this question is interesting. This question, if you see, question number 22 is from the measurement subject. It is from the measurement subject. In which of the following bridges balancing condition frequency independent? Yes, these are frequency independent. सर वो कॉन्सेंट्रिक सिलेंडर वाला कैपेसिटिव ट्रांसफर वाले के क्वेश्चन में इन यूज़ किया है इंस्टेड ऑफ लॉग की प्रॉब्लम नहीं ना. यस गेट विला, लेकिन आई थिंक इट इज स्पीयर, राइट? इट इज नॉट सिलिंड्रिकल, इट इज स्पीयर. I think that is related to some EMT subject. I too also searched for that, but it is not cylindrical, it is sphere. Okay na? So in cylindrical, if we want to do, then we need the length of the capacitor plates, but length of the capacitor plates is not given in that question. I think it is a sphere, that means it is related to electromagnetic theory. In which of the following bridges the balance condition frequency independent? My dear, this is a MSQ hai, this is a MSQ. So the right answer is Maxwell bridge is frequency independent आएगा. Next, sharing bridge भी frequency independent आएगा. But Wien bridge cylindrical, but in the question it is mentioned as spherical, right? But you don't have the length, right? Yes, then there is, I have to consult with the EMT faculty. Once let me confirm, once let me consult with the EMT faculty. Okay, 1 second. I think in the question he has not given any length information, right? If we want to solve this, a capacitor is constructed using two concentric spheres and air as a dielectric medium. The length must be given, right? Length must be given. The length must be given. Yeah, understood, but the length must be given, na? Length must be given. I am thinking it is a EMT question. So if we check as per the basic formula, so we know that C is equal to 2 pi epsilon L log base E d1 by d2. Okay, so here everything is there, but L is not there na. So I thought it is a electromagnetic something will be there. So I said soch. But if it is related to capacitor cylindrical plates, then L is must. If L is not given, he has to give marks for all. If L is not given, yes. It maybe gate villa, maybe. But you have to inquire from the EMT faculty. एक बार सर्च करना है. Spherical is the question ना. I think the spherical is the question. That's what I am telling. It is two concentric cylindrical means this question. Two concentrical spheres na. Concentrical spheres is different, concentrical cylinder is different. Spheres is very clearly mentioned. I think this topic is related to EMT subject. This topic is related to EMT subject. Okay. No sir, this formula is not applicable in sphere. Yes. Yes, Manas Ranjan, that's what I was talking. Gate villa, that's what I was talking. Yes. Yes, yes, that's what I am talking. It is not cylindrical, na? It is spheres. Yeah, just before I told that it is related to cylindrical means you have to get the length, but clearly as mentioned two concentric spheres. So let me talk about the EMT, okay? Then you can. Chalo, let us go for the next question, my dear. Yeah, this one, bridge problem, how many of you solved? So sharing bridge and Maxwell bridge, of course Wheatstone bridge also, but the point here is pure resistor network if you are using, then you can take it. It's a MSQ, multiple select questions. Praveen Dakkar, how many of you got this answer? ACD, how many of you given? So I am going for ACD, my dear. I am going for ACD, Wheatstone, sharing and Maxwell bridge. Yes or not? Wien's bridge is frequency dependent. Yes, right. ACD is the right answer. So let us go for the next question. Next. So there is a very simple questions like question number 24. This is also we can take from the sensors. Question number 24 we can take from the sensor subject. So ये भी a resolution है. Resolution of ADC question. Analog to digital converter है. So you can take a ADC diagram. So this is the ADC. So it is getting the analog input voltage, and this is the V reference, and this is the number of digital bits. So this is the D0 to Dn hai. So the range of voltage is given as 0 to 10 volts. So 0 to 10 volts means these are full scale. So full will be the V reference. So V reference will be the 10 volts. So resolution formula for ADC is V reference by 2 power n minus 1 actually. V reference by 2 power n minus 1. Already in the question resolution he has given. How much he has given? 0.01 volt he has given. So V reference is 10 volts, 2 power n. N is the number of digital bits we don't know. So approximately 2 power n minus 1 is equal to 10 by 0.01 means it is 1000. And approximately 2 power n is coming towards the 1000. So n must be integer, approximately 10 ho jayega. Why? Because 2 power 9 is not equal to 1000, 2 power 10 is equal to 1024. So approximate closest integer पूछ रहा है. So he is asking the integer, so the right answer will be 10. Am I right or not? Yes. 10 bit right. Yes. 10 bits. Understood? So this is a resolution oriented question. Now let us go for question number 25. Question number 25 is a very easy question. I didn't expect this much easy questions from the sensor subject. So this time sensors paper was so easy. So what is the answer for this question? Hall sensor is based upon the principle of Seebeck effect is not right. So this is for thermocouple. Piezoelectric effect, this is also not right. This is for piezoelectric crystals. Next, photoelectric effect, that is also not right. That is for photoemissive cell. So Lorentz law force is the right answer. Why? Because that is a question is when a current carrying conductor placed in a transverse magnetic field, then it is going to experience a force at an angle of 90 degrees like this. when a current carrying conductor placed in a 90 degrees magnetic field, it experiences a force. A Lorentz law hai. Okay, so that is related to Hall sensor, Hall effect we have discussed very early. Photoelectric effect is wrong, my dear. Photoelectric effect is related to photoemissive cell, Lorentz force. Hall sensor ye hai, when a current carrying conductor placed in a magnetic field, when a current carrying conductor placed in a magnetic field experiences a force, so the force comes out of the board, so that is a force, Lorentz law of force, BIL sin theta. Okay, my dear, so that is a basic point, Lorentz force. Understood Gateway law? So the right answer is Lorentz force. So this question is related to Hall effect, very good context. Chalo, next let us go for the next question. Yeah, this question is interesting. Question number 26. So this came from optical instrumentation. Actually this question number 26 is related to spectrophotometry. So this topic is related to spectrophotometry, my dear. This topic is related to spectrophotometry. So what is the question? So there is a sample like this. Okay, so its path length is, suppose let us take some delta x, or x you take it as x, and from there you are getting some source intensity of radiation, this is II, and what comes out is the IT, and this particular sample will be having some absorption. Definitely whatever is transmitted out, that will be exponentially decaying. So I can take this to the receiver side. So the basic Newton's law of radioactivity, Nr is equal to Ni into e power minus lambda t, exponential y is equal to a into e power x, like that. Whatever is coming out, definitely that will be lesser, exponential decaying. So IT is equal to II into e power minus mu into x, like this we can take it. Okay. So in this question, what is asking? Whenever this x is equal to something, the IT is something. So what is given? When x is equal to 1 centimeter, at that time what is the intensity of the radiation transmitted out? So that is given as 0.414 milliwatt per centimeter square. 0.414 milliwatt per centimeter square. When x is given as 2 centimeters, then the intensity of the radiation transmitted out is 0.186 milliwatt per centimeter square, my dear. Okay, so now I can use this equation. Wow, in both the cases I can use IT1 is equal to II e power minus mu x1 divided by IT2 is equal to II e power minus mu x2. I can take like this. In both the cases II gets cancelled. So IT1 we got it as how much? 0.414 units cancel. This is 0.186. E power minus mu we don't know. So this is 1 centimeter and this is e power minus mu, this is 2 centimeters. All of you are following, my dear? So how much we are going to get, my dear? So 0.414 divided by 0.186, if you check it, it is coming as 2.2258. Please take the care of calculation. So it is e power minus mu, antena, minus mu plus 2 mu. Okay, so that is coming as e power plus mu, e power plus mu आएगा, correct? E power plus mu आएगा. So 2.2258 is equal to e power mu. So if we apply the natural logarithm ln, 2.2258 is equal to mu, that's it. So ln 2.2258 is the answer. It is coming around 0.8. So the answer is 0.8 or 0.8. All of you understood, my dear? All of you got it? Photoelectric effect गलत है ना? Photoelectric effect is related to photo light का chapter है. Hall effect is related to semiconductors. Hall effect is related to magnetic field. Photoelectric is related to optical light. कैसा mistake किया आपने? Okay, okay. Enjoying? Yes, mu is equal to 0.8, my dear. Chalo, let us go for the next question. I think हो गया ना almost all questions. Yeah, this question is a very interesting question. Wheatstone bridge का question. Question number 44. How many of you are able to solve this question, my dear? How many of you are able to solve this question? Question number 44. A very good question. Wheatstone bridge का question. How many of you are able to solve this question? Please tell me how many of you are able to solve this question. So if you see this question, a Wheatstone bridge R1 is 1.5 K. So there are two cases when the switch is open and when the switch is closed. Initially when the switch is open, R1 was 1.5 K, R2, R3, R4 was 1 K. So initially when the switch is open, only one resistance will be there. So now initially switch open. When switch open, what is the data he has given? So this voltage was 10 volts. So if you connect this one, this is 10 volts, this is 1.5 K, this is 1 K, this is 1 K, this is 1 K, and he is asking the voltage between the CD. So this is CD he is asking, so this is AB. So what is a VCD, my dear? VCD is nothing but VC minus VD. So VC means we can take it as 10 1 by 2 minus D means this is 1 divided by 2.5. So 1 by 2 means 0.5. So 1 by 2.5 means how much? 10 divided by 25. 0.4. 0.5 minus answer 1 by 10. So answer you are getting here it as 1 volt. Am I right? So VCD is 1 volt. Next, this time this is switch open. Next, when switch closed, what happens to the circuit? The circuit, in addition to this 1.5 kilo ohms, we are getting one parallel resistor. When the switch is closed. Yes or not? We are getting a parallel resistor like this. So now if you see, this is the 1.5 kilo ohms, this is the 30 kilo ohms, and this is 1 kilo ohm, this is 1 kilo ohm, this is 1 kilo ohm. So this is the C and this is the D. Okay. So now how to do this? Very simple, my dear. So this is 10 volts. So first of all, what is this R equivalent? So this combination will become how much? This combination will become how much? 30 into 1.5 divided by 31.5. So that is coming as 1.4285. Okay. So this combination is coming as how much, my dear? So this equivalent is coming as 1.4285 kilo ohms. Am I right? 1.4285 kilo ohms. So VC क्या होगा अभी? So VCD is equal to, so this is 1 divided by 2, 10 minus, this is 1 divided by 1 plus 1 point, how much, my dear? So 1.4285. 4285. So if you simplify, how much you are going to get? Into 10. It is coming as 0.882. So 0.882. So this is the VCD. Okay. So two diagrams, my dear. Two diagrams. From the two diagrams, I can take a small table analysis like this. So what is the table? Let us see here. Let us see here. Okay. So when the R1 is something and this is the VCD. When R1 is 1.5 kilo ohms, when R1 is 1.5 kilo ohms, VCD हमको कितना आ गया? So we got the VCD as 1 volt. You got this as 1 volt. Okay, my dear. And when it is modified 1.5K parallel to 30, that means it's becoming as 1.4285K. 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 So how much we are getting, my dear? How much we are getting here? So this is 0.882. Okay, we are getting this as 0.882 volts. Got it? So what is the sensitivity? Sensitivity is the change in bridge voltage by change in resistance. So that means I can take it as 0.882 minus 1 the whole divided by 1.4285 minus 1.5 units volts per kilo ohm. So how much we are going to get it? So if you check, divided by 1.4285 minus 1.5, so it is coming as 1.645 volt per kilo ohm. So this is the sensitivity. All of you got it? Yes. All of you got it? 26 people are watching. Please like the session. यार instrumentation का कुछ भी कहा भी content नहीं मिलेगा. So please like the session. Please show me some symbols of expression. All of you are watching ना, please like मार दो यार. ये funding company नहीं है. So we need your response. All of you got it? Yes. Chalo. Let us go for any further questions we have it. Khatam. So all the questions I have discussed. This is a general aptitude. That's it, my dear. So these are the questions which we got in the paper. Okay? Right. Yes, low range force. Hall sensor works on the low range force, my dear. When a current carrying conductor placed in a transverse magnetic field, then it experiences electromotive force. The current carrying conductor, the electrons which are moving in the conductor, when they are under the magnetic field, they experience electromotive force. In the given options, it is very clear. Seebeck effect is related to thermocouple, piezoelectric effect is related to crystals, photoelectric effect is related to light, that is nowhere related to Hall. So simply we can understand the Lorentz law is right answer. Okay, my dear. So these are the questions, my dear. Different questions we have discussed. Different questions we have discussed related to the topics. Okay. Chalo my dear, with this I am closing the session. I wish you good luck for your coming exams also. Have you enjoyed this session? Thank you.